Let's have a conceptual discussion about the common ion effect, which is usually how they start in your chemistry class. It's usually how they start talking about buffer solutions, which comes right after the basics of acids and bases. So I'm going to kind of assume you know some of the basics there as I talk about this. Examine this first problem here. Which of the following changes will occur if solid KNO2 is added to a solution of HNO2? All right, first thing I have to talk about. I want to direct your attention to this thing, this solid thing that we're dropping into a solution here. Immediately what's going to happen with this is that it's going to dissociate into a K plus ion and an NO2 minus ion. All right, remember, this is the section on acids and bases and buffer solutions. The important thing you need to know here, and what the common ion effect really does as far as solving problems is concerned, is that you're not going to worry too much about this K+. You're only interested in the NO2 minus, and I'll explain why. Look closely at these two things. HNO2 as opposed to the NO2 minus ion. What do they have in common? Obviously some NO2s, but more specifically, this is going to be the conjugate acid of this, or rather this would be the conjugate base of that acid. If you pluck an H plus ion off of the NO2, you get NO2 minus. So now that we've established that, let's throw out the K completely and just talk about what this ion does. So if I have a solution here that's sitting in a container already, it has HNO2, which is aqueous. And if that solution is sitting there all by itself, then what happens at equilibrium is that it's going to separate into H plus ions, as well as some NO2 minus ions. All right, cool. Now let's think about what happens when we actually take this NO2 minus ion, or rather the salt, the KNO2, which effectively is just the NO2 minus, and think about how what we're doing is we're kind of adding more, well, of this, right? We're going to take this process that has already happened inside the acidic solution and add more of that, the NO2 minus ion. And now what we have to do is we have to think about Le Chatelier's principle, which is really quite simple, right? We're just going to say if we disturb the equilibrium condition of a solution, of a system, then what the system is going to try and do is shift things to relieve the stress on the system. Think of it like this. Specifically, if we have to take NO2 minus and add it to this system, what the system wants to do is release the stress that comes from having more stuff on this right side. So we're going to shift the system to the left here. If we're shifting the system to the left, that means that instead of proceeding in the forward direction, this reaction is going to start to proceed in the backwards direction, at least the way I've written it. We're going to get H plus ions and NO2 minus ions combining, absorbing each other and forming new HNO2 molecules, right? So let's talk about specifically what this is doing, right? We got some things going on. We're going to decrease the amount of H plus ions in solution, right? Because the H plus have to get absorbed into the mechanism that creates the HNO2. If we're decreasing the H plus, then we're making the solution less acidic. Hence, we are increasing the pH, right? Remember that? Anything greater than 7 would be basic, and anything less than 7 on the pH scale would be acidic. So we're going to increase the pH if we're going to make it less acidic. The next thing we're going to do, obviously, we're going to be increasing the amount of, okay, I have no idea what that says, excuse me. We're going to be increasing the amount of HNO2 molecules that we have. Obviously, right? We have to shift the equilibrium to the left so that we create more of this stuff. And finally, What happened to the NO2 minus? Well, I mean, I'm just saying we dropped NO2 minus ions into solution. Obviously, we increased the amount that was already there. Yes, some of it gets absorbed, some of the new NO2 ions get absorbed into the reaction that sends us this way, but not all of them. Net, we have an increase in NO2 minus an increase in HNO2 and an increase in pH. Therefore, if we look at our options here, we have a couple of good ones. Okay, increase of pH is there. That one is true. How about the decrease of Ka thing? Well, that's complete nonsense. That Ka, that is the acid dissociation constant. That is merely a property of the acid in question, HNO2. We can't change the property of the acid. That's not what we're doing. We're just changing the solution that it's in. So obviously, that one's nonsense. I'm not going to highlight that one. Increase in NO2, did that happen? Surely enough it did. That's one of our things that we listed off as an effect, so that's true, which of course means that the decrease in NO2 minus is not an option. And these two are the correct answers to this problem. Okay, next problem. It's similar, let's approach it similarly. Which of the following statement is correct when solid NH4Cl is added to a solution of NH3? Just like last time, I want to investigate this solid that we're adding here. What do we get that's important? Out of this, we have an NH4 plus ion and a chlorine ion. Just as before, it's the NH4 plus that matters because that happens to be the conjugate acid of the base NH3. I am not worried about this chlorine. Now that I've established that, let's investigate the solution itself that's sitting there. NH3, which is an aqueous solution, is going to tend to become OH minus because it's a base, and NH4 plus. All right, now, remember what I did last time. What we're doing is adding more NH4. Adding more of this. We may have a basic solution as opposed to an acidic solution last time, but make no mistake, this problem is exactly the same. Just before, when we used Le Chatelier's principle, we increased the amount of stuff on the right, which means this system is going to shift over to the left, which is going to do what? On one hand, we will decrease the OH minus concentration. And from your basics of acids and bases, remember that if we decrease OH, we increase H plus. We make the solution more acidic, and therefore we decrease the pH. Next thing we do, obviously we made more NH3. Let's increase our concentration of NH3. Finally, we dropped NH4 plus ions into solution. Some of them got absorbed into the reaction mechanism, shifting over to the left, forming NH3, but not all of them. So we have an increase. Wow, my handwriting's really off today. An increase in NH4 plus. Let's look at our options, see which answer is correct. Option 1, concentration of NH4 increases. Oh, this one's decreasing. We know these two increased. H plus increased, NH3 increased. So option 4. The concentrations of all NH4, NH3, NH plus, all of that increased. So number 4 is the correct answer to this problem. Very, very well done.